All right, so I just want to remind you a couple things about equations of lines. Do you remember graphing equations of lines from last year? Y equals mx plus b. Does that sound familiar? Yeah. And m stands for what? What is m in the equation? Mx plus b. M is the what for the line? The slope. Yeah, obviously. Slope starts with m. Yeah. Right? And b stands for but y-intercept, right? I feel like I looked up once why they use M and B, and I can't quite remember now. But anyways, that's what they use. And I want to remind you something about the slope. Slope can be positive or negative. Positive slopes, as you're walking from left to right, will always be going uphill. And negative slopes, as you're walking from left to right, will always be going downhill. And I like to draw these little, I call them slope triangles when I'm doing this. And if you remember, slope is rise over run. So rise and run. Rise and run. And slope is always, it doesn't matter whether it's positive or negative, it's always rise. Oh, I'm in trouble reading today. Rise over run. Yes. Yeah. Sorry about that. Yeah. So I'll tell you that I'd say probably when we get to geometry, 90% of the mistakes that people make when they're graphing lines is they get the wrong slope in terms of positive or negative. So if you could kind of train yourself, always double check when you're doing your rise over run, and just double check and ask yourself, if I walk from left to right along this thing, would I be going uphill or downhill? And is that what I want? Okay. Because that's usually where people make mistakes. They usually get a pretty good idea about how to do the y-intercept, but the slope and the sign on the slope is where people tend to make mistakes. So here we go. We'll do a couple examples. I'll have you practice some on your own. Now, this first one doesn't have the slope as a fraction, but you know how to turn a number into a fraction, right? What can you put underneath any number and you turn it into a fraction? We can put it over 1. So I'm going to think of my slope as 2 over 1. And it is a positive slope. So when I graph this thing, I want to expect to see a line that's heading uphill. And I want to be able to count up to and over 1. So that's how we're going to find our next points. We got to figure out where our first point is. And our first point is going to be on our y-axis at the y-intercept, which in this case is -5. So if you would, please go ahead and draw a dot on your y-axis at -5. Make sure you're getting that on your y-axis, not your x-axis. And put your pencil down at that point, and let's count our slope off, and we'll draw some more points. So I'm going to rise over run. So I'm going to go up 2 and over 1 and draw my first point. And do a quick visual check on that. If I were to put a line through those 2 points and walk along that line, would I be going uphill? Yes. If I walk from left to right along that, would I be going uphill? Yep, and that's what we want because this is a positive slope, right? So we're good. Let's do a couple more points. Up 2 over 1, up 2 over 1. I might come back to this point and go backwards, down 2 over 1, the opposite direction. Enough points that I can kind of get a nice accurate line. By the way, if anybody wants rulers, there's a wooden box of rulers on the cupboards over there, the little shelves. Help yourself. You don't have to have a ruler. You can use the edge of a book or whatever too. I'm going to use a ruler though. When you are drawing these lines, I do want to see a line that goes all the way across the graph. And would the line end at the edge of the graph? Or would it keep going? Keep going, how far would it keep going? Forever and ever, to infinity and beyond, but you can't go beyond infinity. And how do we indicate that it would keep going forever and ever on a graph? Let's put arrowheads on these. So let's get in some good habits of actually drawing the arrowheads on there so we know that this is a line and not just a line segment. A line segment would have endpoints on it. Oh, you with us? Why don't you put that in your backpack just so it's not a distraction for you, please? Thank you. All right, we got one done. Does anybody else want a ruler? See the wood? Oh, yeah, you got it. Anybody else want a ruler? Feel free to go grab one. I bet Brady would bring you back one if you asked him. Anybody else want a ruler? Brady's a pretty nice guy. All right, you guys good just freehanding that? Fantastic. All right, next one. Now this one is a fraction in front of the x, so I know that my slope is going to be negative, and I am going to just sketch that off to the side to remind myself that's going to be negative. This time when I do my slope triangle, I'm going to count down 3 and over 2. We need a starting point. Our starting point is at positive 1 on the y-axis. Positive 1 is right there. And then from that point, I just need to count off my slope, which is down 3 over 2. So 1, 2, 3 over 2. Boom. And I'm going to do a quick visual check. If I were to draw that line right now, if I were to walk that line from left to right, am I going downhill? Yes, I am. Okay, so I did that the right way. I'll count off a couple more points, down 3 over 2, down 3 over 2, maybe back it up and get a couple more up here. I find that the more points that I draw, the more accurate I can be with these. And there's our second line. All right, line number 3, this one's tricky. There is no number in front of the x. What number can we always put in front of a variable if there's none written? You always put a 1 in front of it. And we know we can turn that 1 into a fraction by putting a 1 under it also. So we can think of this slope as 1 over 1. Because 1 over 1 times x is just going to end up being x. And it's a positive slope, so I'm expecting this time when I draw my line that I'm going uphill, like the first one that we did, because it's a positive slope. And when I'll do my rise and run, it'll be 1 over 1. So up 1 over 1. This time around, we are starting from -4 on the y-axis. So finding -4, putting a dot there. And then from that point, we'll count our slope up 1 over 1, up 1 over 1. Maybe go backwards a little bit. And you're out in. All right, any questions on those first 3? Before I ask you a question. This question is not written on the page, so those of you who are working ahead, I want you to pay attention to this. Do you have any questions for me before mine now? I want you to look at these 3 graphs that we just made. Zoom out, Tom, you can do it. Yes. And tell me, which of these 3 graphs is the steepest? Which one is the steepest? Graph number 1, graph number 2, or graph number 3? So if you got an idea, just show me 1, 2, or 3 what you're thinking right now. We'll see a little bit of everything. No, that's not true. I'm not seeing any number 3s. Seeing 1s and 2s. All right, I think we can agree that the last one is not as steep as the first 2. And by steep, I'm not talking about positive and negative can both be steep, but which is steeper? Graph number 1 or graph number 2? Pretty evenly split between 1s and 2s. Anybody want to back up their claim with an explanation? Why you think it's 1 or why you think it's 2? What do you think? If you look at how close the line is to the y-axis, I like that description, right? Like, so if my line was like really close to the y-axis like that, then it's really steep. And you think this one looks like it's closer to the y-axis? Okay. All right. I'm not going to say that's right or not. Anybody want to weigh in on number 1 or number 2? Another explanation for number 2?
Kind of similar to like she said, but also on a hill,
Mhm.
it'd be a more steady incline versus second one where it'd be very
Mm-hmm. Okay, so you're imagining yourself. So you're kind of applying a story to it, which is a great strategy for math. You imagine yourself hiking up it, and you think the second one or the first one looks steeper. The second one looks steeper. Okay, awesome. So if you were hiking, normally we go from left to right, but if I was hiking from right to left, you think this one looks steeper than this. Cool. Anybody want to weigh in on number 1? Number 1's the right answer. Someone give me a reason that number 1's the right answer. What do you think? Because it is. Okay. Thank you. I like it. Ooh, I like that. So I think if I'm understanding, are you talking about the y-intercepts? So you think it's kind of a visual trick because the y-intercept's lower, it doesn't look like it's as steep? Huh, I like that. All right, I can tell you the number 1's a steeper one, for a fact, 100%. And I didn't look at the graphs. I'm not looking at the graphs because it's hard for me to tell looking at the graphs. I looked at the equations. Well, what part of the equation tells you how steep a line is? Slope does. That's what slope measures, right? And if a slope is a bigger number than the line is steeper, right? So I look at my slope here. My slope is 2/1. 2 divided by 1 is 2. My slope is 2 here. And my slope, ignoring the negative for right now, here is 3/2. What's 3 divided by 2? 1.5, 1.5, right? This slope has a bigger number. So this line's steeper. Pretty cool, huh? You're right. I think it's the y-intercept that tricks your eye into thinking it's not as steep. But this one definitely is steeper. Cool. That was a great discussion. Thank you for everybody who weighed in. It's okay if you were wrong about that, right? Because that gives you an opportunity to learn something. So in the future, if I ask you which line is steeper, what are you going to look at, the equation or the graph? We'll look at the equation, okay? And I want you to keep that in mind because that's going to come into play with something we're going to talk about a little bit later. So right now, if I could get you to please complete the rest of the graphs on the front page. If you got that done already and you want to kind of move on to the back, I've got some blanks on the back for some notes, and then there's some problems. You can go ahead and try out those problems and see what you can do with those. If you're not quite sure, then just kind of sit tight for a moment. Give me a moment. I haven't taken attendance. After I've taken attendance, if you'd like to move and help someone out or walk around and help people out if you're finished with them, you're going to be graphing 8 lines here. 2 on each graph, okay? And if you spot any mistakes up here, let me know because I worked through these pretty quickly. I'm just going to go through and visually check my lines. Again, remembering that when we talk about sloping positive or negative, we always think about moving to the right. And if it's positive, it's going to be moving to the right and uphill. And if it's negative, it's going to be moving to the right and downhill. So as I visually check these 2 lines, I do have positive slopes on both of them. And both of them, as I move from left to right, I'd be going uphill. So I'm feeling good about that. This graph, I should have one going downhill and one going uphill because of the negative slope and the positive slope here. So here's my downhill one, here's my uphill one. So I'm okay with that one. Number 6, both lines should be going downhill because they're both negative. And some of you probably changed those 2's into 2/1s. And then number 7, we got one of each, positive and negative. And I am seeing one that's going uphill and one that's going downhill. Do you guys spot any mistakes with any of my graphs? Okay, thank you. Thanks for checking for me. There is something special about the last 2, and many of you clued in on the title of our notes for today. What is special about the lines in number 6? They are, which one? 6 or 7 is one of them is perpendicular. 6 is parallel. 6 is parallel. These lines are parallel. Can somebody give me a quick definition of what parallel means? Mm-hmm. You have the key. You have the key. Something is the same about them. Yes. What is the same about them? They never cross. And what's the same about them? They're running kind of in the same direction. They have the same steepness. And we measure steepness with what in the equation? With the slope. Did anybody notice that the slopes were exactly the same in number 6? That's an important property of parallel lines. Slopes are the same. I'm going to write that down on the back side of our sheet in just a moment. Do you all know how to abbreviate the word parallel so you don't have to write it out all the time? This is not a number 11 right here. This is the abbreviation for parallel. Basically, you draw 2 vertical lines that are parallel to one another. Do you know how to abbreviate perpendicular? It looks like an upside down sheet. And I'm super happy that you said perpendicular. You were talking about number 7. These are perpendicular. Can someone give me a definition of perpendicular lines? They do intersect, but what's special about how they intersect? Yes. Lost it? What's special about when, say again? They cross each other, but these lines cross each other too, and they're not perpendicular. What's special about how these ones cross each other? What's special? They make 90-degree angles. They make right angles. If I held up the corner of a piece of paper to this, it would fit in there perfectly. That's because this is a 90-degree angle. So these are perpendicular. And what do you notice about the slopes of these 2 lines? They're not the same. Something's opposite about it. I'd say 2 different things are opposite about it. What's one of the things that's opposite? So one's positive and one's negative. So the signs are opposite. And what else is different about them?
Flip the numbers on, or which one's rise? They flip rise over run.
They flip rise over run. Yeah. And there's a really fancy vocabulary term for when you flip a fraction. Does anybody know it starts with an R? Reciprocal. Okay. I think we're ready to take our notes. So parallel lines. For our purposes today, I'm going to assume that we know what parallel lines are. I think you've seen those probably since elementary school. But really, we want to talk about today how parallel lines have equal slopes. Now, it might be worth writing down a definition for perpendicular lines. We know that perpendicular lines They do cross each other and they form 90-degree angles. I'm going to say form right or 90-degree angles. That's what's special about perpendicular lines. Perpendicular is a very important concept in geometry because when we start talking about shapes, some special shapes have perpendicular sides. Can anybody give me an example of a shape that has perpendicular sides? A square has perpendicular sides because it has 90-degree angles. A rectangle has perpendicular sides. A right triangle has perpendicular sides. So these two of them are perpendicular. So we'll be using the idea of perpendicular a lot. For our purpose today, we want to talk about the slopes, and this is a wonderful math term. Perpendicular lines have opposite, reciprocal slopes. Opposite, reciprocal slopes. When we say opposite in math, we are typically talking about positive or negative. And when we say reciprocal, we're talking about taking a fraction and flipping it on its head. So let's practice this a little bit. We'll work through number 8 together, and then I'll have you do the rest of the problems on this page, and we'll come back together and chat about the last few, because there's some tricky ones on here. All right, so the slope of a line is 5/2. If I had another line that was parallel to that, what would its slope be? Got to be the same thing, because parallel lines have equal slopes, right? So a parallel line would also have a slope of 5/2. But the slope of a perpendicular line would be different. We got to do two things. We need the opposite. So whatever the sign on this is, we need the opposite. That was a positive, so I need a negative. And we also need to take the reciprocal of that fraction. So flip it over. 5 was on the top, now it's on the bottom. 2 was on the bottom, now it's on the top. The slope of the perpendicular line would be -2/5. You get the idea? All right, let's do one more together. I'm going to do number 12 together. And then I'll let you finish up the rest, and then we'll chat about them. Number 12 says, write the equation of a line with ... Okay, they're asking us to write the equation of a line. When I write the equation of a line, I know it's going to look like this. Y equals, I'm going to have a slope. I don't know what it is yet, so I'm just leaving a blank spot there. And then X. And then it's either going to be plus or minus something, and that would be my y-intercept there at the end. So basically, I just need to fill in a couple different numbers. So write the equation of a line with the y-intercept of -42. So the y-intercept is the thing that comes after the x. It's not attached to the x, so that's going to be -42. And we want our line to be parallel to the line y equals -1/16 x plus 3. What number am I focusing my attention on in this equation to help me find my slope for my new line? The -1/16. That's the slope of this line. And if we want it to be parallel to that, then we need to use the same one, or do we need to change it? Same exact one. So we're going to use -1/16. And there we go. We're finished with that problem. We have written the equation. All right, so that's what you're going to be doing in 13, 14, and 15. Please finish up 9 through 11 on your own first, and then work on 13, 14, 15. 14 and 15 are tricky problems. See what you can do there. I'd be happy to give you some hints if you need. Go ahead and work on this for a couple of minutes, and then we'll be done with our notes. Lots of time to spare. All right, well, let's talk through. There's a tricky one up above too, but let's talk through these. So slope is 1/6. If I want a line that's parallel, it's going to have the exact same slope. So that's also negative 1/6. The slope of my perpendicular line would no longer be negative. Now it's going to be positive. And I need to take the reciprocal of my fraction, flip it over, that's 6/1. I would like us to get in some good algebra habits and simplify that. 6/1 is 6. And if you didn't simplify that, that's okay. Go ahead and do that now. Yes, it is the same thing. But one of the things that we like to do in math is make our answers as simple as possible. All right, this time I got a slope of 5. If I want a parallel line, it's going to have the exact same slope. For the perpendicular line, I need to change the sign. It used to be positive, so now it's going to be negative. And how do I flip a 5? We could turn this into a fraction, 5/1, and now it's easier to flip. It would be 1/5. Good. All right, don't miss this next one. If the slope of the line is 0, the slope of the parallel line would be also 0. Now this is tricky. Don't miss this. What is perpendicular slope for a line with a slope of 0? First of all, take your pencil right now and hold it up and show me, what does the slope look like? What would a line look like if its slope is 0? Remember, slope measures how steep something is. And if the steepness is 0, then it's just totally flat, right? Totally flat line. Now, turn that pencil 90 degrees and show me what the perpendicular line would look like. It would look like that, wouldn't it? That doesn't have a slope of 0. That would have a slope of what? How steep is that? That is like super steep, right? It's more than 100. 100 would still have a little bit of tilt because it'd be up 100/1. This is perfectly up and down. 180 would still have a little bit of a tilt because you go up 180 and over 1. This is perfectly straight up and down. What is the slope of this? It's kind of close to infinity. But we don't talk about vertical lines as having any kind of slope. We would actually say that the slope is undefined. Because it's vertical. Vertical lines have slopes that are undefined. Little mathematics for you. This is a little borders on philosophy and kind of the end of the universe also. So check this out. If I wanted to turn this 0 into a fraction, how do I turn any number into a fraction? Over 1. All right, now I'm going to make my perpendicular slope. Now, is 0 positive or negative? Trick question. It's neither. It's the only number that's not positive and not negative. So we can't really flip our sign, but that's okay. Let's talk about the reciprocal of this. If I were to take the reciprocal of 0/1, it turns into 1/0, and that's problematic. Can someone tell me why that's problematic? Yeah. You can't have 1/0. If I have 1 of something and I want to divide it into 0 equal parts, that's just conceptually not possible. What is the one number you're never allowed to divide by? Because if you could actually succeed, the universe would collapse in on itself and everything we know and love would cease to exist. Right? You cannot divide by 0. You can't do it. Mathematically, this is undefined. So this is why we say a vertical slope is, or the slope of a vertical line is undefined. So that was a kind of a tricky one. We talked about 12. Let's get an answer to number 13. Y equals, I know my y-intercept is 13, so I'll have a plus 13 at the end. All I need is my slope. I'll focus in on my slope here, but we want perpendicular, so I need to flip that. Let me go ahead and put it over 1. So that's positive. We want to make ours negative and then flip that fraction. Did you have negative 1/4x plus 13 for number 13? Right. I saw several people working on number 14 and making some good progress on it. Couple keywords here. Our line is going to go through the origin. Where is the origin on a graph? It's at 0, 0. This would be the origin, right? So if I have a line that's going through this point, what's the y-intercept going to be? The y-intercept is 0. So when I tell you it's going through the origin, that's a sneaky way of me saying that the y-intercept is equal to 0. All right, so that was sneaky. And also the slope's going to be sneaky because if you have an equation in this format, you cannot look at that equation and tell what the slope is. The slope is not 8. A lot of people think that the number in front of the x is automatically the slope. That's only true if the equation looks like this. So our process is going to be, we're going to take and get this y by itself. We're going to solve this equation for y. So I saw many of you start this process. You did minus 8x. Zoom in a little bit here. You did minus 8x on both sides to cancel those. That got us negative 3y equals, and then we can't combine these together, so I'm just going to bring them both down. I am going to choose to put my x first because that's kind of closer to what I want it to look like, right? I want that to be something x plus something. And then all I need to do now is get rid of this negative 3. When we divide in the equation, we have to divide everything by the same number. So it's y equals, what's going to happen to my slope if it's a negative divided by a negative? Negative divided by negative is positive. Okay. So that's going to be 8 over 3x. And then positive 9 divided by negative 3 would be minus 3. So this equation and this equation are the same equation in a different format. That's the same line. Well, now we can look at this and see what the slope is. It's positive 8 over 3. We want our line to be parallel to that. So our line will also have a slope of positive 8 over 3. So our equation is going to be y equals 8 over 3x plus 0. Right? Because we said our y-intercept was 0. A better answer for that would be just y equals 8 over 3x, though. Again, if we can simplify, let's make things as simple as possible. That one was a tricky one, wasn't it? How many people were able to get pretty close on that? Please figure out what the slope was. I saw several people as I was walking around. And some of our Algebra 1 classes spent more time focusing on taking an equation like this and turning it into this last year than others did. So consider yourself lucky if you've seen it. You'll be doing a lot of this, not so much this year, but next year in Algebra 2. All right, last one. Last one here. All right, we need to write an equation. Y equals something, blank x plus something. This is going to be our new equation. What's the easy part of this one? There's one part of this that's relatively simple. The slope or the y-intercept. What do you think? Slope is pretty simple because to tell us we want it to be perpendicular to this line, and we can see what the slope of that line is. We don't have to do a bunch of work like we did in the last problem. So what's our slope going to be if it's perpendicular and the slope here is negative 3 over 2, positive 2 over 3. Problem is, I don't know what the y-intercept is. They told us the x-intercept, and that is not useful when we're writing an equation. The x-intercept is 6. I hope that you learned this really well last year in Algebra 1, but let's just see. If I'm told the x-intercept is 6, can you give me the coordinates of one point that you know for a fact is on this line? Oh, I'm hearing someone say 0. It does have to do with a 0 and a 6. Question is it 0, 6 or 6, 0? 6, 0 or is it 0, 6? You're sure it's 6, 0? Yeah, because it's an x-intercept. Yes, it is 6, 0. So 6, 0 is on the line. So here's how you're going to do this. And if you were at the high school last year for Algebra 1, I know that you did this a couple times. We're going to rewrite our equation here. Y equals 2 over 3x. But I'm just going to leave this as a b right now because I don't know what it is. Is this looking familiar to you? And then we are going to substitute in some numbers for x and y. What numbers am I going to substitute in for x and y? 6 and 0. We'll put 6 in place of the x and 0 in place of the y. And now we have an equation that we can solve and figure out what b is. And we'll just do like one step of algebra to make that happen. 3 over 2 times 6. Are you comfortable doing that in your head? You can either do the 3 times the 6 and divide it by 2, or you can do the 6 divided by 2 and multiply it times 3. When you're multiplying by a fraction, you're basically multiplying by the top number and dividing by the bottom number. 3 times 6 is 18, divided by 2 is 9. Or 6 divided by 2 is 3, times 3 is 9. Either way, it's 9. So we got 0 equals 9 plus b. And you can probably solve that in your head. What's the only thing you can add to a positive 9 and get 0? Negative 9. B is negative 9. Now we've got the final piece of our equation. All right, you guys did awesome today. Thank you for your attention through that. We have a pretty good chunk of time for homework today. I've had some issues in some of my other classes with people not utilizing their homework time when I give it to them. Okay. I would really love for you to get started. Some of you are going to finish it. It's a relatively short homework assignment tonight. So please make it your goal to get it done or get most of it done. It'd be awesome if you could walk out of here and not have to worry about anything tomorrow afternoon. Just have the afternoon off, right? So I'm going to go ahead and put it up here. You're welcome to get your computer out to work on it on your computer, or you can go back and grab one of the books. If you would like to move your seat and sit next to someone else and work with them, that's totally okay. In fact, encouraged. We're basically doing 76 to 80 in the book. If anybody has not logged on to the online textbook, please do that right now. I'm getting emails from people saying, I can't get onto the online textbook. I can't help you from home. Okay. So if you haven't done that, I need you to do that now because there's nothing I can do. So make sure you check that. And I will be around to answer questions. This is a question for the greater good or an individual question? I'll be right there.